In this lesson, we're going to look at inverse functions. We're going to make sure that we understand an inverse function switches x and y. We're going to determine if a function is one-to-one. Given a graph or table, we're going to evaluate f inverse of a. And finally, we're going to draw the graph of an inverse function. All right, so at its most basic, inverse functions are about undoing an action. So what's the inverse of the following? Tying your shoelaces? The inverse would be to untie. Climbing the stairs? The inverse would be to go downstairs. Putting on a coat? The inverse would be to take off the coat. Now when we consider inverses, we should watch what happens to our input and our output. So for instance, our input on tying our shoelaces, we'd probably start with an untied shoe. And once we tie our shoelaces, we would have a tied shoe. Now when we are untying our shoes, we would start with a tied shoe. And when we're done, we would have an untied shoe. And I want you to see how our input became our output here, and our output here was our input up here. Same thing with climbing the stairs. Let's, for instance, assume that we started on the first floor here. After we climb the stairs, we might end up at the second floor. But if we were to undo this action, our input would be the second floor, and when we go down the stairs, we'd end up at the first floor. So notice in our inverse function, our input and our output swap places. We're going to do this on this graph now. And if you pull out your green assignment pack, you will find that the rest of the notes you can fill in on the page right behind the assignment sheet. All right, so what we're going to be doing is switching input and output. So let's take this very first point over here at negative 4, 0. When we swap x and y, we end up at 0, negative 4. So we're going to plot that point, 0, negative 4. We can go to our next point right down here at 0, negative 2. And when we switch x and y, we end up at negative 2, 0. And just like these points are connected, we're going to connect those 2 points like so. And then next, we'll take our last point that we need to finish the graph. This is out here at 4, 2. And when we switch x and y, we end up at 2, 4. And we can connect that to the last point. And we have just drawn the inverse. So this blue one was the original function f. And in red here, I have f inverse of x. All right, here it is drawn even more pretty. And I want you to see that there's actually a line of reflection that goes along here, and that line is y equals x. So the graph of the inverse is a reflection over the line y equals x. All right, let's next consider the domain and range of f of x. So f of x is the one in blue here. So our domain, let's see, our smallest x value is negative 4, and our largest is positive 4. And our range, if we look, our lowest y value is at negative 2, and our highest y value is up here at positive 2. Now let's find the domain and range of the inverse function, which is in red right up here. So let's look at the domain of our inverse. Smallest x is negative 2, and the largest is positive 2. And our range, our smallest y value is down here at negative 4, and our largest y value is up here at positive 4. And we should see how the domain of the function became the range of the inverse, and the range of the function became the domain of the inverse. And that makes sense because domain is x values, and when we switch x and y, down here they become our y values, which is our range, and our y values in the range here become our x values here. All right, so we're now asked in this situation, or we're told, that f inverse is not a function. So take a look right here at f inverse. Why not? Well, we can draw this line right here, and we can see that it fails the vertical line test. Now on the original function, if I took similar points, I could draw them like this. This would be kind of similar to what I just drew there. And you'll notice on the original function it was a horizontal line. So could we have known that before graphing f inverse? Yes. We could have tested f of x, so the original, with a horizontal line test. All right, so now we have a new term. A function is called one-to-one if each input has one output and each output has one input. So a function just has to have each input having one output, but for it to be one-to-one, it has to go both ways. Neither x nor y can repeat. A one-to-one function passes both the vertical and horizontal line tests. And finally, a function must be one-to-one for its inverse to be a function. All right, so let's look at our parent functions, and here they are. Which ones are one-to-one? Well, this one fails the horizontal line test. This one looks good, one-to-one. This one also fails the horizontal line test. This one's good, so it's one-to-one. And this one as well is one-to-one, which is to say they pass both the horizontal and vertical line tests. Let's look at this table. Which of the functions shown to the right is one-to-one? Well, we can see that the x's don't repeat. And then if we look at a of x, let's see, none of these repeat. But if we look at b of x, we're going to see, oh look, there's two 5s. So this one is not one-to-one, but the one that is one-to-one is a of x. All right, so now we're going to go through these values from a table and figure out what they are. So first, a of -1. We've done this before. We plug in -1 and our answer is 4. I'm going to get rid of some of these extra arrows here. Now what we're going to do is go backwards. When we do a inverse of 4, the input is our y value. So we're going to go in the a column, find the 4, and our answer is now going to be an x. Because when we do inverse, our input is the y and our output is the x. Let's try another one. So in the next one, we have a inverse of -1. So we go in the a column, we find -1, and we're like, okay, it's going to be 3. For the next one, we've got b inverse of 9. Now, even though this isn't one-to-one, the 9 only shows up once. So we take 9 and that matches up with an x value of -2. And then we can do the same thing with b inverse 2. This is where b equals 2, and so our answer is 0. And the reason we're working backwards is because these are all inverse functions, so our input and output switched. All right, let's try this also on a graph. So we're going to start with g of -2, which is what we always did before. G of -2, we go to this point right here, and our y value is 1, because this is at the point -2, 1. So our input is -2, and our output is 1. For the rest of them, we're going to work backwards. We're going to be looking for the output. So here we have g inverse of 1, and we're going to say, well, where is our y value 1? Our y value is 1 right here, and I go across here, I get to that point, and I get -2. There's my x. You'll notice it's just the opposite of the one we did before. When we plug in an x of -2, we get a y of 1. So if we plug in a y of 1, we get an x of -2. All right, let's try another one. This time we have g inverse of -3. So since it's inverse, -3 is our y. So there it is, -3. We're going to go across to this point, and it matches up with an x value of 4. Let's try the next one. G inverse of 0. We're going to go where we have a y value of 0, and our answer is going to be -1. So we can see also this is the point -1, 0. So we were plugging in the y, we got an x value of -1. One more. Here we've got a y value of 3. So here's a y of 3 that goes across to this point. This point's at -4, 3. So when our y value is 3, our x value is -4. All right, the last thing we're asked to do is to draw the inverse. I would encourage you to pause and do that and then check afterwards. All right, so let's take a look at what we have here. Let's start on the left. -4, 3 is going to become 3, -4. There it is. All right. Let's see, here's the next point. -2, 1 is going to go to 1, -2. And those were connected with a straight line, so I'm going to connect them with a straight line here. Let's go next to this point here. 1, -2 is going to go to -2, 1 right here. And then our last one right here at 4, -3 is going to be at -3, 4. And you'll notice, oops, that's a +4. And you'll notice that this curved out like that, and it's going to do the same thing like that. And you should notice that it does still reflect over the line y = x. All right, so that should be enough to get you going on homework number 6.